Hello, and welcome to another Nordic API's LiveCast. These curated hour-long webinars bring together some of our community's top experts to dig into specific, complex topics related to all things APIs. And today, we'll be diving into GraphQL best practices, and we have an excellent cast here with us today with a lot of experience to share. And I think this is perhaps one of our best lineups so far for one of these LiveCast events. So I'm really excited. And for this event, we have William Lyon of Neo4j. William is a software developer working on the open source graph database, where he works on building integrations for graph databases and helps developers build applications with graphs. He is the maintainer of Neo4j GraphQL.js and a contributor to grandstack.io. Prior to joining Neo4j, William worked as a software developer for several startups, building mobile apps, quantitative finance tools, and predictive API services. William holds a master's degree in computer science from the University of Montana. And William's going to be talking about building full-stack serverless GraphQL APIs in the cloud. So we're going to follow him along as we learn how to build a GraphQL API using Apollo and the Neo4j database. So really excited for that. William's also going to be speaking at our upcoming conference in Austin in mid-May. So welcome to the LiveCast, William. And next up, we're going to have Carlos Rufo, who describes himself as, let's see, astroturfing an open source software developer that loves JavaScript. He's a GraphQL enthusiast and sporadic stargazer, believing the best code is always no code. Carlos is pretty involved with the GraphQL community, contributing to platforms such as howtographql.com and recently creating the SpaceX GraphQL API, also writing posts and collaborating with tooling. And today he's going to be talking about end-to-end type-safe GraphQL apps, where we're going to discover the steps and benefits for adding end-to-end type safety to your GraphQL apps with his demo-based talk. So thanks for joining us with this LiveCast, Carlos. And then next and last up on the LiveCast is Jesse Martin. Jesse's a brand lover, technology champion, and all-around nice guy. After years spent in digital strategy and software development, Jesse is on a mission to show developers there is a better way to work with content on the web. When he's not building databases about wine or comparing deep technical topics to cake layers, he spends his time with his wife and 2 kids, trying to combine his love for faith, family, friends, fitness, and food. He may or may not be in the middle of an 18-hour fast and apologizes in advance if he seems grumpy. This is my first time reading this. I dig this. Yeah, much respect for the fasting there. So in this talk, Jesse's going to provide a descriptive and powerful interface for data discovery, collection, and selection. With recent developments in developer tooling, it's possible to take our schemas one step further by stitching multiple APIs together into a single elegant API for collecting all our data in one place. So we'll explore the next level of data mashups with schema stitching and GraphQL. And I should have gone through like this, 1, 2, 3, but didn't. Get your questions ready. We're doing this in real time. If you as a viewer do have any questions for our speakers, we're going to allow a 5-minute Q&A after each lightning talk. So the talks will be about 15 minutes each, give or take. And yeah, then we'll open the floor up for discussion. All you need to do that with is a YouTube account, so just make sure you have that ready. But before we dig into William's talk, I would just like to give all of our new users here an introduction to Nordic APIs. Basically, we're an international community of API enthusiasts. We're holding events all over the world. It kind of started in Stockholm with a yearly summit. We've branched out to host an Austin summit each year as well. We've been running a high-impact blog with 2 long-format pieces per week on all things APIs, from marketing to security, design, new implementations and new standards. So it's a lot of fun. We get to review new tooling and dig into new innovative complex topics on the web. So I'd recommend following that if you're into the LiveCast today. And we're also publishing some ebooks. We do have one on GraphQL out that kind of combines our best blog posts on the subject. And a little bit about our community. Like I said, we do the events and the blog, and we bring together some thought leaders and bloggers, API owners and practitioners to share their thoughts on the blog. We also have people using APIs and creating mashups and sharing that sort of interest with our readership. And then people like API tooling specialists who are digging into how can we manage and create gateways for APIs and different frameworks for accessing GraphQL, etc. So that's kind of a little bit about our community, and our goal is to create programmable worlds. So that's kind of the end purpose here. A little bit more about our blog. If you, we were just talking before we started about how it's pretty difficult to get developers to write. If you are one of those rare few who do enjoy that, consider submitting to the blog. We have just a great platform for you to share your ideas. So if you're interested in that, contact me at bill@nordicapis.com. And like I said, our Austin API Summit is occurring from the 14th to the 15th this May 2019. We have nearly all of our speakers lined up. We're at the very last legs of organizing. It feels pretty good at this point. We're just selling tickets now, and I think early bird is done, but you can still grab your normal pass. The day before that begins is workshops. We are offering a practical server-side GraphQL themed workshop on May 13th, and that's going to be presented by OKGrow. So if you like the GraphQL theme, consider signing up for that as well. If not, we're offering some open API spec theme workshop there, and digging into advanced OAuth and OpenID Connect, which gets a lot of attendees. And our yearly platform summit, we have set a date for that. It's going to be October 21st through the 23rd in Stockholm, like I said. So call for speakers is now open for this event, and you can just view our website for more information on that. Like we did last year, we have a Best API of 2019 competition likely scheduled. More news on this. And if you're interested in what we did last year, you can check out the blog. Ring Central went home with the prize. But we're going to do this again and probably announce the winner at 2019 Platform Summit. And if you like our content, like the stuff, try signing up for our newsletter. You'll get a bi-weekly digest of the most 3 recent posts that we've published, and some just brief, sporadic information on our events. Like I said, there's plenty of ebooks and other stuff to dive deeper on the website. And I think there's my introduction. I'm assuming like a lot of us are pretty familiar to GraphQL or interested in learning how to get the best of it. So I'm going to hand things off to the people who can talk a little bit more accurately. So let's bring up William here. Stop presenting my slides. All right.
Okay, there we go. So hi, everyone. I'm going to be talking about building full-stack serverless GraphQL applications in the cloud. That'll be a little bit of a whirlwind, but it should be fun. So like Bill said, my name's Will. I work at Neo4j. I work on a team that is focused on building integrations. So I work on our GraphQL integration. I also work on a data visualization integration. And then I spend a lot of time working with developers, just helping them build their applications. So if you have questions after today's event, feel free to reach out either on Twitter, or my email address is there on the screen. So what I'd like to cover today is really sort of a focus on how to build GraphQL APIs. And we'll take a look at a couple of different approaches. We'll take a look at how to deploy them. We'll take a look at how to extend GraphQL. So really, I want to focus on just giving you an idea of the different concepts and the different tools that are available to help you build your GraphQL API. So with that, let's get started. So first of all, what is GraphQL? Well, I'm going to assume, like Bill said, that most of us are familiar with GraphQL, at least at a high level. But the important concepts here are that GraphQL allows us to describe our data with type definitions. It allows the client to request exactly what it's interested in, and then the results match the query exactly. So the client is only getting back the data that they've requested. Another important observation that GraphQL makes is that your application data is a graph. So if we're talking about users that have made orders that contain products that are fulfilled by some other vendor, right? This is a graph, and we should reason about that in the client, regardless of how we store that on the back end. So let's take a look at an example. So imagine we have data about movies that are in genres, directors and actors that are connected to the movie, and so on. How would we build a GraphQL API to serve that data? Well, the first thing to note is, like we said, GraphQL allows us to define and describe our data. And we do this typically with GraphQL type definitions using the Schema definition language, or SDL. There's other ways and other APIs to build up these type definitions, but using this SDL is the most common. Now, another important concept is this idea of introspection. So this just means that our GraphQL schema itself can be queried. And that means that the schema then becomes our API specification and documentation. So tools like Graphical or GraphQL Playground, and this is a screenshot on the right here of GraphQL Playground, they allow us to explore our GraphQL API. So we can see the entry points. So here we have queries and mutations. So queries and mutations are the entry points for our GraphQL service. Queries are the reads, mutations are essentially the writes. But we can also explore the different types and the fields available on each type, all as a result of introspection. So here's an actual GraphQL query, and a query is composed of a few different parts. I've linked a blog post down at the bottom, the anatomy of a GraphQL query, that really helped me understand just the different terminology and the different pieces involved in a GraphQL query. But in our example query here, basically we have an operation name, so that's movie, and some arguments, in this case, the title, which is A River Runs Through It. And then we have our selection set. And this selection set is defining the fields that we're interested in bringing back. And we're only going to receive results for the fields that we specify in our selection set. And notice that our selections can include arguments as well. Now, really, this query, so here we're saying find the movie A River Runs Through It, give me some information about the movie, like its title, find the actors it's connected to, find its genres, find the directors, and then also find other movies those directors are connected to. Really, that's specifying a traversal through this graph of movies and actors and directors. In our response in GraphQL land, looks like this. So this is JSON that matches the structure of our GraphQL query, exactly the data that we asked for in the query. So a few more observations here. First of all, GraphQL is an API query language. not a database query language. And that's an important distinction. There's limited expressivity in GraphQL, so we don't really have concepts inherent in GraphQL of things like projections or aggregations, things that we might be familiar with from database query languages like SQL. And the other important observation is that while GraphQL exposes our data as a graph, it's not just for graph databases like Neo4j. We can use GraphQL with really any data layer and even wrapping other APIs. So let's take a look at an example API, and then we'll see how it's built. So if we look at the community site for Neo4j, this is a discourse forum, and at the top here, we have these activity feeds of popular projects and popular blog posts in the community. And this content here, so everything above the fold here, this is actually loaded from a GraphQL API that's available publicly, so communityapi.neo4jlabs.com. And this is GraphQL Playground. So this is a great tool for querying and exploring, working with GraphQL services. So the first thing I can do is inspect the schema. I can see the different entry points. So I have one here, top community blogs and content, and I can see that all of this is typed, right? So this query gives me a list of community blog objects that have a title, a URL, then they're connected to an author that has some more information associated with the author. So I can query this, let's say top community blogs and content. Let's look at just the first three, and then let's get the title and the URL. And so here I see, okay, these are the current top blogs. And as I add more fields to my query, then that data comes back as well. And this exact API is what is powering those activity feeds that we saw on the website. Okay, so that's nice. Let's take a look at how we would actually build this GraphQL service. There's a blog post that goes into a bit more detail on this that talks about this community graph instance. So we have a database instance that has all of this information about blog posts and GitHub projects and the users that have created them. But really, this is the process that we go through. We first start with our GraphQL type definitions. So things like a community blog type, a user type. We specify the entry point. That's a special type called query. And we're working in JavaScript here, so that that GraphQL schema, those type definitions become just a string. And then the next piece is to define our resolvers. Now, resolvers are functions that define how to actually fetch the data for our GraphQL schema. And each resolver has a similar signature. It's passed an object, so that's the bit of the GraphQL query that's been resolved thus far. Parameters, so any arguments to our query, and then a context object. And this context object is where we might do things like inject user authorization information or database drivers so we can connect to a database. And then inside this resolver function is where we may need to check our authorization information, query the database, maybe massage the data that comes back a little bit to get it into the format that we expect. So for our trending activity feeds, this is a Cypher query. This is the query language we use with Neo4j. And we basically define a resolver that says, hey, run this Cypher query to fetch the data, grab that database driver out of the context, connect to the database, and then massage the results a little bit to match the data that our GraphQL service is expecting. And again, this is a JavaScript example. And here's the rest of the implementation for this GraphQL service. We use Apollo server. So Apollo makes tools for both working on the server side and GraphQL client side as well. And there's a nice function here, make executable schema from Apollo server that we can use to basically combine our type definitions and that resolver function to give us an executable GraphQL schema object. We also create our database driver and inject that into the context here when we create an instance of Apollo server, passing in our executable GraphQL schema. And then we can serve that. Apollo server uses Express under the hood. So this is basically a Node.js Express app that's serving GraphQL Playground and our GraphQL API. Okay, so that's sort of what I phrase as the standard approach for building GraphQL services. You have some type definitions, you implement some resolvers, maybe you create a data access layer that defines how to fetch the data, you call that in your resolvers. But there are a few common problems that pop up with this standard approach. Things like schema duplications. We're maintaining a schema for the database and for the API. This mapping and translation layer, so that has to be defined in our resolvers. How do we actually fetch the data? How do we map it and translate it to match our GraphQL type definitions? There ends up being a lot of boilerplate code. You saw where we're connecting to the database and massaging the results. And then this idea of an N+1 query problem. And we didn't see it here because we were running just one Cypher query, but imagine if for each one of those blog post objects that came back, we then had to hydrate the user object as well and be making multiple requests to the database. So to solve some of these reasons, there's a whole community really of tooling called GraphQL engines. I'm not sure if this is the correct term to use. This is what I've seen others in the community use to refer to these sorts of tools. So we'll go with GraphQL engines. And these are really tools for auto-generating a GraphQL schema, generating database queries for us from arbitrary GraphQL requests. So basically things that can help us build GraphQL APIs without writing a lot of boilerplate code. And some examples of some of these tools are Prisma, AWS AppSync and Amplify, which expose your AWS services through GraphQL, Hasura and PostGraphFile, which both work with Postgres, and then Neo4j GraphQL, which is a tool that I work on that I'll speak just a little bit more about since I'm more familiar with that tool. And really, the idea here is this idea of GraphQL first development, that we take our type definitions and that drives the database model. So you're not maintaining two schemas, rather you're driving the database from GraphQL type definitions. Then we want to be able to generate database queries, in this case, Cypher queries for any arbitrary GraphQL request. And then finally, we mentioned before that GraphQL doesn't really have this concept of more complex projections, aggregations. So we can extend GraphQL by adding a Cypher schema directive. So this allows us to define computed fields that map to a Cypher query in our schema. And this integration is available as an NPM module. It's intended to work with any of the JavaScript GraphQL implementations like Apollo Server, GraphQL.js. I'll skip the demo in the interest of time here, but really the idea here is we define our type definitions, and then we use Neo4j GraphQL.js to auto-implement both our resolvers and the query and mutation fields. So we're not having to define how to fetch the data from the database or to define the entry points for our API. That's all taken care of by our integration. So that's the idea of GraphQL engines, simplifying the approach, making things more performance by generating just a single request to the database. So another topic I wanted to talk about is this idea of extending GraphQL. And what we're talking about here, in one example, is this idea of the schema directive. So we saw that Cypher example, and a schema directive is really just sort of an annotation that we can add on the schema that specifies that there's some logic defined on the server that should be implemented. And this allows us to do things like possibly add authentication. There's an NPM module that allows us to add authentication with schema directives. And I'll skip through that a little bit quickly, but the basic idea here is we can annotate our type definitions with these schema directives to define the authorization rules for types or individual fields in our schema. The last thing I want to mention is just some ideas for how we can deploy GraphQL services. So I've broken this up into two sort of approaches here. One is the more what I'll call traditional approach. So with our JavaScript example, we really had just an Express app. So we could host that and deploy it any of the standard ways that we might deploy an Express app on a platform as a service, such as Heroku or Elastic Beanstalk, in a Docker container, on a VPS somewhere. But then there's also this other serverless approach, and we could use something like AWS Lambda, Google Cloud Functions, or Azure to deploy our GraphQL service on a functions as a service offering. And there are three separate services that I've listed out here: Serverless Framework, ZiteNow, and Netlify, that go beyond sort of the developer experience that you would experience with the standard functions as a service like Lambda or Google Cloud Functions, that allow you to do things like deploy from GitHub and that integrate really, really nicely and easily with this more modern approach for deployment. So I've highlighted those specifically. And then finally, I just want to touch on a few resources. First of all, is we looked at some JavaScript examples, but there are GraphQL implementations in lots of different languages. Java, Python, and Ruby that I've highlighted here are some of the most common. There are lots of other GraphQL implementations. It's not just the JavaScript world. GraphQL clients. So we didn't talk about this too much. Apollo client is probably the most common. It has front-end integrations with lots of the different front-end frameworks. But there are other alternatives that can be a bit more lightweight, and really we can use almost any HTTP client. That example that I showed with the community page for Neo4j, that's just using Fetch. And finally, a couple of resources for reading more. There's the Open GraphQL Medium publication that I really like. It has lots of resources from the community. You can find the demo that I didn't show today on the GrandStack starter project. And then finally, GraphQL.org has sort of the official documentation for working with GraphQL.js. Okay, so that was a bit of a whirlwind, sort of how to build GraphQL APIs. And if we have any time left, we can take some questions, I think.
And your posts, thanks for all the posts and linking for different information throughout. But if we really want to dive deeper, are you going to be demoing a little bit more at Nordic APIs in Austin?
Yeah, exactly. So so we skipped over, how do I actually deploy this on serverless frameworks in the cloud, and in Austin, we'll definitely get in a bit more detail on how to do that.
Cool. Well, yeah, thanks so much for walking us through that standard approach for creating type definitions, implementing resolvers, creating data access layers. But like you said, we noticed there's a lot of issues with that standard approach, like schema duplication, boilerplate code, and more. So yeah, it's a great overview of new ways to leverage GraphQL using those engines, as you mentioned, and also some new methods that I'm myself not as familiar with, like schema directives. I was kind of wondering, can schema directives be used for other sort of functionalities other than just authentication, like you mentioned? And
yeah.
Of any specific examples?
Yeah, absolutely. There are actually some packages that bundle up custom schema directives that you can import and add to your schema. So things like validating data format. So if you want to validate that a field is an email address, things like that. And there is actually a package, this is another Apollo project from GraphQL tools that allows you to implement your own custom logic. It gives you a nice API to basically define a schema directive visitor that implements whatever custom logic you want to. So you can think of this as sort of wrapping a resolver is a way to think of it.
Okay, interesting. Yeah, I guess just so our viewers know, we are taking questions from the community in real time for our presenters. If you have anything from Will that you want to ask a little later on, we can try and get to that. But in the sake of time, I think we'll just move on here to Carlos. Yeah, thanks so much, Will, for presenting, and really excited to see you in Austin.
Great, thank you.
Yes, so can you see my slides, guys?
Looks good on my end.
Okay, cool. So I'm gonna start. I'm gonna be talking today about end-to-end type-safe application, in this case with GraphQL. So presenting myself, I'm Carlos. I've been for the last 4 months working as open source developer related to the GraphQL community. And you can find me on the internet, in Twitter, GitHub, Medium as SW Carlos. So the agenda for today, we're gonna see what is a type-safe GraphQL application, and why TypeScript loves GraphQL and how they work together. And then we're gonna just see like a live coding in order to create both TypeScript and GraphQL API and a TypeScript and a React client with, of course, hooks. So probably, hopefully it's gonna be exciting. So when we're talking about type-safe application, this means that we have to have our database backend and frontend implemented with a strong type system language. So, but also we don't have to have all these types from the database, backend, frontend, matching all together through all your application. And it is like an interesting point of the application, because it is difficult to achieve. So when we are building, evolving, or creating APIs, we have to care about type system, predictability, tooling, and probably documentation, versioning, other topics, right? But we are gonna just go through about these 3 topics. So about type system, the majority, we know that majority of the backend sites they have built implemented on static type language, right? Like Java and C++, or even like TypeScript. But when we are sending all our payload to the client, we are missing all these advantages of have a stack type implementation, right? So the good thing, as William mentioned before, is GraphQL allows you explore your API where you can see all your types and all your entry point fields. And with that, we can achieve an incredible superset of tooling as GraphQL, which is an in-process API, and we're gonna see today what is like how the auto-generate types works, and also extension for your editor. But the main point in order to achieve an end-to-end type-safe application, it is whether you are gonna create that single sort of truth. And doesn't matter if you wanna create from your database, you can create your data model, and from there you are gonna extend your types to your backend side and your frontend side, or you can do even from your GraphQL schema definition, and you are gonna extend your type to your resolvers and also to your frontend, which is what we are gonna do today. So I'm gonna be using the GraphQL code generator tool. It is open source. It was created by the Guild, and I want to give a shout out to them because they're doing a really good job. And basically, we're going to use a schema first approach in order to create our GraphQL server and generate all this stuff for our resolver and our client. So just let's start. We are gonna just start our GraphQL server. We're gonna see what we got here. So we got our index where we have our schema and we have our context with our database, and we got our GraphQL, which is Squillion. So before it's just Apollo server with the schema and the context. So if we see the schema, we got all our type definition structured by domain. So if we see the rocket, we got our type definition and resolvers. And the good thing about SDL, it is like, I think it is super reliable. We do have like these cons about the code duplication and type safety, but what is interesting is like we do know that all this data is defined, and GraphQL is going to ensure that all this data, the data that you are representing, in this case, when we are going to ask for rockets, we know that we are going to return an array of rockets. And if we don't do that, GraphQL is going to go through a validation phase as it's going to return an error. So it could be really good if we could take advantage of all this type system in order to auto-generate all our type, in this case for our resolvers. So let's go first to our API. So we can just go, we see, okay, here we have it. So localhost 4000, and we got GraphQL playground, and we can just fetch all data as we want. We're gonna get rockets, so we can just go and get all the rockets ID and name, right? So we get the same chat, amazing, a documentation, auto-generate documentation type, and always up to date, which is a huge win. Then also I'm gonna get the rocket ID, and I'm gonna just do Falcon 9, right? I'm gonna get that data and the response. So that's pretty good. So, but like I do know about all this information, right? So I wanna auto-generate. I'm gonna use GQL Gen, which is the graphical code generator, to auto-generate all the types based in my schema definition. So if we see our code gen file, what we have is we are gonna find for all our TypeScript files in our schema folder, and we are include the context, and we are using the TypeScript plugins, and then we are gonna auto-generate this file, the type DTS that we have here already, in order to know all our types. And it is just great because we got more than 4,000 TypeScript type working out the box. And if we see in our query, we got all our entry points, query fields, where let's say that we're gonna get rockets. So in rockets, we do know that we're gonna get a maybe of a maybe array of rockets, or a rocket is gonna be a maybe of rocket. And that rocket is gonna contain all our TypeScript type definition based in the GraphQL schema. And this is just good. But how we can achieve, we are gonna add this type. So the good point from here is that when we are in our resolving our type definition, I wanna know whenever I evolve in my API, right? So let's say that now I wanna just evolve my API here. I wanna just call it ID. So this is not gonna work, right? Because I'm gonna have here ID, but I didn't change my rocket because I forget it, right? So I do wanna have a runtime check in order to know that I have to change this ID. So if we see here, if we go to our types, we are gonna see that something just changed. So in our types, in our auto-generated types, we do know that it changed. So if in some way I could type my resolvers, in this case with co-resolvers, I gotta get a runtime error in order to avoid production or error. So I could just simply just introspect, go to ID, and do ID, and send. If I want to evolve my API, I wanna, let's say that I wanna just create a new query field, which is gonna be rocket by name, and we're gonna get a name, and we're gonna get a string. So I wanna evolve this. So the same, if we go to our types, we're gonna see that we include the rocket by name because we are auto-generating our TypeScript types based on our type definition. So if I wanna call my API, I don't wanna care more about my type definition. I just wanna generate all the types, and what I'm gonna have here is, if I look for rocket binding, I already have it, and this is gonna be saying an async function, which is gonna contain some methods, and it is just good because we got the object, we are not gonna use it, but the argument I declared before in my type definition are name. So if I can destructure the arguments parameter, I get the name, and I got even if type, which is a string. And same happen with the context. I can destructure the context, okay, my database, what I'm gonna use it here, and then I'm gonna just find by name. So whenever now we are just deploying our server again, we can restart our server, and we are gonna see in the GraphQL playground, whenever it's ready, that now ID is not here because we just changed it. You are gonna get the data, but also you can just go and look for rocket by name, add the name, and just with another Falcon 9 and get the name and the cost plan, for example. And you get the data, which is just amazing. It's a huge win. So before go to the client, I would love to say that I've already seen a lot of articles about what is better, GraphQL, REST, or SOAP, or RPC, and GraphQL versus REST. No, I think like it could be really good if GraphQL loves REST, right? So I don't know if you notice it, but when I've been when I saw the index, we got here our GraphQL file, which is the Apollo server, but also we got a REST where we are passing the config with the schema context. So taking the advantage of the GraphQL predictability, we are gonna auto-generate a REST API with several of the GraphQL appendices basically from our GraphQL schema. So we are using SOFA, also created by the Kill. And we are gonna use OpenAPI to create our REST API. We're gonna expose it in our Express instance, and then we are gonna also export our REST documentation in our base path, with this case is /REST. So if I go back, if I can type here localhost REST, I'm gonna get an auto-generate REST API with auto-generate documentation type, and everything working out the box. So it's just amazing. So let's go into the client right now. We're gonna do same. We're gonna create the client. We're gonna start it, and we're gonna see what we got. So here we have our index, where we got so we have our index where we have Apollo provider. We are gonna use React Apollo hooks in order to take advantage of hooks and GraphQL with Apollo, where we have to pass a client, which is the Apollo client for Apollo Boost. And we have just to, insert the URI. And then we have our application, which now we're just using fetch, which is a hook, and we are using our REST API. And then we are using use query, which is coming from React Apollo hooks. I totally recommend React Apollo hooks if you want to start using hooks with GraphQL. And then we are going to pass the query that we want. So now we are just doing 2 requests just to see what overfetching looks like. And then we are just going to see, and then we are going to get the data that we are returning. We are just display the mission name, the rocket name, the details, and the image, right? So let's see first what overfetching looks like. If we see the REST endpoint, we got 300 kilobytes with 5 seconds, and in GraphQL we just got like 64, which is this is a huge win in terms of efficiency. And we can see here that we got our 74 launches with all these huge payload that we are not using, and this is a common issue in the actual APIs, and we have to avoid it. And if we compare with GraphQL, we get the same, our 74 launches with just the payload that we want. So this is just amazing. And just to finish it, what I would like to show you guys is like how we can take advantage of that predictability of GraphQL in order to evolve or to have better user experience in the client. So first, if we can do introspect our schema from our in-browser API IDE, I think it could be really good if we can do the same from our editor, right? So there is a visual code station from Apollo, so we can just go and enable it, which allows you to introspect your schema based in your API. So you can just get this file where you are gonna introspect the server that we are actually running, and with a few clicks, with a control space, you are gonna get, hopefully, yeah, we got it. So we got all our data from our languages, and that's amazing because I don't have to go to the documentation. But also, I would love to take advantage of all these type systems in order to provide to auto-generate all the TypeScript type based in my GraphQL document, in this case, in my query. So we could auto-generate DQL gen with the same configuration. We got our code gen file where we are gonna introspect our schema from this URL, and then we're gonna find all documents from our source folder, and we're gonna generate our types based on this plugin. So if we see what we got here, we got our types, and we got exactly what we're looking for. So we have our get launches with our query, which is right from our launch path, but it's gonna have like this mission detail links and rockets. So let's see how we can evolve our client with an incredible developer experience. So we are gonna type our returning data. We can just remove the rest endpoint. And now what I wanna do is, okay, I'm gonna just commit these changes, and we're gonna see what happened right now here. So whenever we are just looking for new data, we can just introspect our schema. I'm gonna get the shape, and from the shape, I'm gonna get the name, the ID, I'm gonna get the name, I'm gonna get the port. With even, I can just use an alias in order to don't have to write all these annoying client parser function, and probably like an image, right? So when I save in here, I'm just telling to my tooling from auto-generated types that I have to auto-generate all these new types. So if we see what is the div here, we've seen that we just added the new zip type with all these fields and all these types. So this, what allows me, it is to avoid first go to documentation with Apollo Visual Code Extension, but also I don't wanna do more console logs. So I can just go to my type definition, and I'm gonna get my shapes, and then if I wanna just like display the shapes, first I'm gonna go, it's an array, so I can use map, and then I'm gonna just return an fragment probably here, and then we can see what we got inside of every shape. So we got autocomplete about the fields that we got, in this case, name, port, and image. And now I'm just gonna quickly do, we're gonna do fancy icon and the name, and then the port, and then to finish everything up, we're gonna just like show the image with image, and then we're gonna just give it like small weight to them. So now when I save in this, I do know that whatever I wanna return in my front end, which is should be here, I got an error, which I don't know what it said. Okay, so just there is the fragment, sorry. So when I just saving this, what I know it is that the data that I'm actually displaying, it is gonna appear, and that's gonna be sure that I'm getting the name, which is funny. The of course still loves you is the name of the ship where the rocket is gonna land, and getting all this data. And GraphQL is going to provide you all this amazing developer experience. So yeah, I think that it covers all of it. So if you want, we can just jump into the Q&A.
Cool. Wow, Carlos, thanks so much. I mean, that's a lot of features to walk through in 15 minutes, but you cover it really well.
Thanks.
I mean, you gave a basic overview of, using type definitions for your GraphQL schemas, using React, Rocket, and all the other tools you mentioned. Seems like there's a lot of little benefits and features in this approach that seem really helpful, like the auto type definition generation is kind of cool, and the highlighting involved with those changes when you're going back and forth in your workflow. It's also interesting to hear you say how GraphQL and REST love each other, and it's cool to see you like generating the open API schemas or specification with the schema, and seeing it all work in tandem for that SpaceX example is pretty cool. Yeah, I feel like type safety is a topic that isn't as discussed, but it's pretty important. It seems to me like having great type safety can help with onboarding and learnability with GraphQL implementations. Would you think that's true?
Yeah, I mean, totally agree with you. I think it's gonna be a nice topic to discuss about for the, I don't know, like next year or this year probably.
Yeah.
And it is difficult to achieve an end-to-end type-safe application, but I'm pretty sure that we are gonna see new tooling, new ways, for example, as code-first approach in order to create GraphQL schemas, in order to provide an easier way to have or achieve this type-safe application.
Gotcha. Do you say that because you're working on something?
Yeah, I mean, like not at all, but I've tried schema first, resolver first, and code first.
Yeah.
And I can see the pros and cons about the different approaches. It is difficult to say which one is better because I think it is related to your project requirement or your application requirement. But I'm kind of sure that something is gonna come up, and we're gonna have almost by default all these type safe. At least what I could have to try to have it is in the front end, because
right.
in the server side we did have it for a while, but we are missing all these nice static types in the front end. And I think if we can avoid console log and all these null checks, it could be really good in order to provide a faster development process.
Excellent. Yeah, I just want to open the floor. Any questions from our speakers, maybe, for Carlos at this point?
Yeah, I don't have any questions. You go ahead.
So my question for you, Carlos. So you talked about sort of being able to find errors quickly with type safety. But I'm curious, is there also a performance benefit or performance hindrance in addition to better visibility of errors?
Yeah, I mean, like I'm not a master in this topic. What I can see is, for example, when you are like running your GraphQL server in a terminal and you are running your GraphQL generator instance in another terminal, it is not efficient at all, right? Because you are, doing a lot of stuff just automating this type, and you have to watch it, and you have to create again and override it and all this stuff. So I hopefully think that if you could have all these processors merged together in the same GraphQL deployment, it could be really nice. But I'm not sure if that applies to have a bad performance of when you are deploying your GraphQL implementation.
All right, I think we'll leave it at there. Thank you, Carlos, the advocate for type-safe, beautiful GraphQL front ends. Really appreciate you being involved in this LiveCast. Hope to see you around, Nordic guys, in the future.
Thanks.
All right, and last but not least at all, we have Jesse Martin from GraphCMS. GraphCMS.
Yep. Let me go ahead and share my screen here.
Sounds good.
So the two previous talks were really interesting and very in-depth and technical. This is going to be a little bit more of the maybe immediately practical and showing just kind of how the end game is and what you potentially can accomplish once you have the GraphQL in place. So enhancing APIs with schema stitching. Schema stitching, the core idea is really basic. You're going to take multiple APIs from different sources and you combine them into an end product. So in this case, we have the 3 different shapes, and then the vision is to combine them into a singular endpoint where you can access all the different data. The idea here then is so that the client is going to make a request to your master API, and then that will hit a proxy layer that then splits up those requests to different resources. You can use REST endpoints, you can use any other kind of endpoint you'd want to use, and obviously it works really well with GraphQL itself. And it's basically going to be broken down into 4 simple steps. First, you're going to be introspecting the API, and we saw that the first talk. So you have to tell your server to go ahead and check everything that API has to offer. So this is when you're working with a true GraphQL API. It loads on that endpoint, and then it checks to see all the fields and all the types that are coming with that. And then you're going to be able to bring it on to the next slide. There we go. You bring it on to renaming the API. So a lot of cases, if you're talking about 2 different developer projects, it's going to be a situation where maybe you have some type name clashes. Most of the tooling around schema stitching or schema merges at the moment basically say last person in wins. And so you can specifically decide how you want to handle any kind of a name collision. And I'll show that in some demo code a little bit later. The next step is going to be connecting the fields together. So you need to tell them which fields are going to be added to which types, and it'll make more sense here when we look at the demo code. But you need to say, okay, how does this actually connect? So if you were to say from the previous example with the hotels, does that go on my location field? Does that go onto the conference field? And then last but not least, you need to then actually resolve those types and be able to say, where's that data going to be fetched from, and how do you actually resolve the data between the different endpoints? The major players in the space right now on schema stitching that have the most robust tooling are going to be either Hasura, which has a very nice GUI interface around it, or Apollo. And Apollo has probably the best server infrastructure that I've seen. The libraries they have are really good, and I would recommend them a lot. And that's what we'll be using for the demo code. Stitching pros, you basically have one API to rule them all, which is definitely a win. So you don't have to worry about trying to orchestrate different round trips between a whole bunch of different endpoints. Even if you're talking about the benefits of GraphQL, still having to hit multiple GraphQL APIs can be a bit of a nightmare if you're trying to have to just do waiting and time management. You have one API to discover it all, so you can actually use those introspection queries to be able to see all the data you have available across all of your different microservices or the different services you're putting together. And you have a visually smaller attack surface. So you have one endpoint that's exposed to the clients typically, and then that's the one place you need to be protecting and looking to make sure that everything is up to best practices for security. The cons, so you have one API to crash them all. So if you have that one API that goes down, obviously then everything is down. It's not going to be partial data. It's lights out, game is over. And it's not always a good idea. So just because you can put all your endpoints and all of your data into a single API, you may have situations where some data actually has a realistic longer time to live than another one does. So you need to really be smart about that. One thing GraphQL does really well is it gives developers a lot of freedom, but at the same time, if you give a developer a lot of freedom, there's also the room for a lot of risk. And then it requires proxies. I put a asterisk on that because a lot of times you'll see best practices around GraphQL actually involve proxies anyways. So this may or may not be a total, bad idea or a con to say, but it is something to be bearing in mind, is that you need to have some service actually combining them together. So that's it for the slides. I'm going to show you then the actual demo code here. And I have here a very simple conf-QL. So I'm going to show you two servers here. So first of all, I have a very simple server setup that is resolving geocode information from Google. So I have a GraphQL endpoint where I pass in a string. It does a geocode reverse lookup, gives me information about the place, and then it passes that data onto Dark Sky API and gives me weather information. So it's a very simple concept that we can do a quick look at, see how that functions in practice. So if I go ahead and say, okay, location, place, and I'm in Berlin tonight. I'm going to go ahead and say that the weather is going to be in Celsius, so brace yourselves. And I get the actual readout where I'm at. I get extra data in there as well, city, whatever else. So it's a nice way to take two actual REST endpoints and put them into a GraphQL endpoint. And then from there, I went ahead and stitched that with my actual database of content. I'm going to show you what my content API looks like. This is GraphCMS, the company I work for. Here's my database of entries. We have a built-in API Explorer. So if I go to conferences, I can actually type. There we go. I'm able to explore the data that I have available. You can see that there's a bunch of other information that I have on that endpoint, but this is just the endpoint that I'll be working with to stitch it in with that weather information. And then I have a bonus API that we'll be adding in as well. So moving to the actual stitching, I have make sure I have the right product here. Yeah, compQL. So here we actually walk through the process of using Apollo to stitch together the different endpoints. I'm working with my weather API here on this top line. And then I have my content API. And then I'm going to be actually adding in Yelp's new GraphQL API as well to pull in some location data. From there, I'm going to go ahead and kick it off by, I have a helper function here. What this does is it wraps the individual API endpoints and does the introspection query on that, and basically says this is the data that is available on the endpoints to bring in. So from there, we have creating these remote schemas. So I have the remote weather API now. So this is a constant that's aware of all of the fields that are available on that weather schema. My content schema, and then oh yeah, you can see my token. I'll have to cycle that later. Then you can see the Yelp API. All right. And from there, we go ahead and transform those. So because my content API supports mutation queries, I actually have a lot of excess fields on there, a lot of excess types on the endpoint. So I wanted to remove the bloat on that to what I want to show my end developers. So I remove all fields that don't match the query operation. And then I have a type collision on my content API with my weather API. So I go ahead and rename the location field from my content API to GCMS and then the actual name of the location. I also have a collision with location on the Yelp API. And so in that case, I also remove any of I rename the locations to place. So far we've seen about the actual introspect the queries, renaming the APIs, and then here's where we actually connect them. So we say where we want to attach the fields. So on conference, I actually want to have location. Here's some bloat that I can remove. Might go there. I have location, and then on the actual location type, I have hotels and food. And when you keep moving further on down, we connect all the APIs together. So we have the remote weather API, we have the transformed API, we have the Yelp transformed API, and we merge these schemas together with my actual types. Pass this into the resolvers and telling it how we actually want to have the data be combined. So and here's where it gets to be a little bit of the magic. On my conference type, I go ahead and say I want to add this location field. And on that location field, I want to go ahead and pass in this, this bit of data. So a query on my conference API endpoint, city, country, and start date. Then I am telling it which schema is responsible for resolving that data, what the operation is, in this case a query, the field name on that remote API, so the location field. And these are the arguments to pass in, place and date. I do the same thing again for location, where I want to add the hotels data and the food data from Yelp. So Yelp is getting the, so location, hotels is searching for anything with the actual hotel keyword. Here it's just hard-coded, but you could make that dynamic. And food, I've just automatically hard-coded in a burgers search because nothing else really matters. All right. So when you have your API then combined, we can open up the API Explorer. And what that allows us, let's go ahead and test to make sure everything's connected. I'm limiting it to 5 responses because these are all free API keys that I'm using, and it would quickly use off my resources. Another benefit of GraphQL schema stitching is that if I'm not actually requesting the data that's related to, say, the dark sky API or my geocode data, it won't actually, it won't cause me any issues as far as it won't hit the APIs, the endpoints. It'll just ignore them because I'm not actually requesting that data. So from conferences, I'm going to go ahead and pass in the name of the conference. And then I'm going to look for the actual location information. I'm going to grab the weather. I'm going to grab the moon phase because it's always important. I'm going to go ahead and look for hotels in the area. I'm going to go ahead and look for the food options in the area as well. If that all works together, we actually can get a response of the conference. This is actually historical data because it's passing in the date to the dark sky API. And then we get the businesses, so the hotels, and then the actual burger joints that are all going to be for that conference and passing on. Apologize for my family waking up in the US. All right, so that is actually it as far as the code I wanted to show, and I will now move it on to questions. So anybody has specific questions on what I showed there? I don't hear anybody.
Hey, sorry.
Good.
Awesome.
Just gonna turn this off here.
Cool.
There we go.
Yeah. Really impressive overview of stitching together multiple APIs. I feel like with a little creativity, this sort of process opens up a lot of potential, like synchronicity and new abilities for developers. Is that the end benefit? Adding additional functionalities within APIs without too much bloat. Like, what do you think is the end benefit here?
The end benefit is that you get that single API endpoint that combines all the different data pieces. So if you want to ship, like, for example, in this case, we connected a static conference listing, pulled in historical data. You could also just refer that to real-time weather data that wouldn't live in a database. And then also hotel listings or whatever else. You could have a lot of real-time data connected to your existing database and have it be accessible via one API. That's
excellent.
That's the promise.
Yeah. You also mentioned some cons, having one API to destroy them all. Is that a real issue with this kind of approach? Like are there safe harbors in place in case one of these APIs isn't functional, for example?
There would certainly be the ability to build in safe harbors. Like obviously my code's pretty brittle in this case, but you could definitely have fallback endpoints. You could have a way to catch it on the actual server. Something's not responding to data correctly, default data to respond, something of that nature. Yeah.
If you're smart and cover, all the potential outcomes.
Like I said, GraphQL gives you a lot of rope, but when you give somebody enough rope, there's also a possible negative outcome. So.
Right. Excellent. Any questions from our speakers or comments?
Jesse, do you have any guidelines when you should and shouldn't use schema stitching? Right, like I could see this being overused, perhaps overzealously. Is there cases you can think of where you should not do this and maybe just implement that logic in your existing API?
Yeah. So let's say you have a content database like posts or articles or something of that nature, and then you have an additional database of comments. I would not mix those together, because the time to live for your comments, as far as caching that on your client, is going to be much, much shorter than you would want to have the response from the actual content itself. Yeah.
Okay, that makes sense.
And perhaps there's the issue of optimization, like some of this stitching could cause additional lag. Is that something that you've noticed, and something you can avoid?
I mean, yeah, certainly you can notice it even in this demo example, because I'm hitting 3 different REST endpoints. I'm hitting the Google services, I'm hitting a free time zone database or API, and I'm hitting the Dark Sky API. So it's 3 REST services dependent upon very different infrastructures.
Yeah.
So it's not even close to the speed that GraphCMS natively, for example, would deliver content.
And we all know with versioning and fickle public retirements for APIs, who knows what could happen. But not to say that it's a really cool idea.
Yeah.
I think, there's a lot of potential there.
It's a proceed with caution. It's a great way to get up and started quickly for getting a product out the door, to test something out. In some cases, even ship to production with a well thought out structure. But it does allow you to work quickly with a single API for getting those MVPs up or whatever else it may be.
Nice. All right. Well, I think I'm going to wrap things up for this livecast. I just have some outro slides. Let me bring those up real quick. Okay. Right. So, we had a great cast for this event. Thank you so much to all of you for participating. Thank you to our sponsor, Curity. They host an OAuth server for API security, and they're a big sponsor and co-organizer for all Nordic API's events. So big shout out to Curity. For further information, you can follow Nordic APIs at our Twitter handle at Nordic APIs. We also do have a Slack group together, slack.nordicapis.com, where you can engage more deeply with the community. And like I said, our next event is in Austin. Get your tickets now for the 14th through the 15th event with a lot of great speakers. I think this might be one of our best events to date. A lot of in-depth technical talks. We're going to be covering a lot of ground. And of course, there are the workshops the day before. If you are interested in participating in one of these, I'm totally open to hearing your ideas. You can reach our team at info@nordicapis.com for livecast information. And that is it. That has been our hour-long deep dive into GraphQL best practices. Thank you, Carlos, Jesse, and Will. Hope to see you guys around Nordic APIs in the future. But for now, signing off. Thank you.